Welcome, Wrench Army members, and welcome to an electrifying exclusive. Oh yeah, we're gonna go high voltage this time, and I got everything ready. And you know what? Let me put our little light back on here. And you probably saw, if you guys kind of tuned in early, the top camera is already giving me attitude. It's getting me a little lip already. So hopefully we'll see how far we can get it to stay on. And we've seen this kind of happen in the past. And I finally figured out what it is. It's actually internal, where the power cable plugs in. It jiggles. So you got to jiggle it just right for it to charge. In any movement, it budges and it stops charging. So we'll see how long this will give us. But luckily, I have another camera with an even better view, so we can start seeing some sparks. So we have, of course, Dave back joining early on. He's saying plasma can only get so hot. Well, we'll see about that. And he was also asking, how big of a light bulb did I find? So far I kind of rummaged through what I have to see if this idea even works. And then we'll talk about the design, like how big do we want this tabletop thing to be? And do we want it to be a lot of dragon and he's holding a small orb? Or do we want the orb to be like really, really big? So I started looking for some very round, as round as I can, because we have our traditional incandescent light bulbs like this. I believe this is probably just a little 40 watt. And for this, the bulb can work, it cannot work, it doesn't matter, so we're going to test on this guy first and see, what kind of streamers we can get. I also have a very cool Edison style bulb to see if we can get some different looking effects. And then we can talk about shapes and sizes. Do we want the bulb to be like the column bulbs, the long cylinders perhaps? But we did talk about orbs. So that kind of leads me to believe that you guys want a very round light bulb. And I think getting a giant one is probably the way to go. That way it can imitate a plasma ball as much as possible, rather than like the little tiny ones that they have for, ceiling lamps and things like that. So we'll test on this guy first, see if this whole idea even works, with the 555 timer and getting streamers out of this thing. And then I will go online and see if I can find the biggest round or other shape. If you guys changed your mind and you want another shape, we can incorporate that too. But just to review, for some of you that didn't join the last time, what we got going on while we have this camera. And oh, wow, look at me talking. Like while we have this camera. Let me see if I can fire that back up again. And then we won't use it for a while and allow it to kind of, oh, nope, so it doesn't want to play. So, all right. Usually these cameras are on constant charge, so that way they're always ready to go. But if that cable moves just a little bit, it stops charging that camera. So either way, I have another one. You all know our other third view, and the reason I hooked this one up this way was so that way we can have a really good, you guys can have the closest up view possible, because I think the view from the side is going to be much better than the view from above from the other camera anyways. So I'm just gonna stick this aside because there's a couple more things that we have to hook up to this before we move on to the light bulb and test. So if you look at our board here, you're pretty much familiar with what we got going on. This is the 555 timer circuit that we put together last time. So we have pin number 3 going to our, of course, famed light bulb, and we have our, oh, wrong side, potentiometer here, so we can adjust the pulses and the speed of the pulses. So everything is wired pretty much the same as you saw. We're gonna pick up from where we left off. The only switch that I did was switch this potentiometer. I believe we were using a 10K last time. I went ahead and popped in a 50K, wired up exactly the same way, our 1K resistor here. Now this resistor on this side has nothing to do with the 555 timer circuit. It's merely here to protect our LED. So that's really the only purpose for it. And the potentiometer kind of acts as our second, because remember that the 555 timer is affected by 2 resistors and 1 capacitor. And here's our little capacitor right here. So you might notice this big chonker, here on this side, and this is our MOSFET, because at the end of the day, the current output by this 555 timer here is going to be really too low. And so we're going to hook this up to an ignition coil, which I got here. This is from like a little Powerman, 50 ATV scooter. I tried to find the smallest one that I could possibly find because I didn't know what our enclosure situation was going to be. My original idea was to go with the cone version, like the older cylindrical style that has a snout going up and then two little inputs, because I thought maybe we were going in the candelabra or tall candle type of direction, and that's kind of got the shape already, so we would be, pretty much there. But if we were gonna do a cool table lamp with dragons and things, I need a base that's small that I can hide with blue cheese crumbles, like from before. We need to be able to hide this base, whether it's a wooden box. Maybe the dragon sits on top of this wooden box in it, and we put the scene on top of that, and we come up with some kind of like old looking antique-y, maybe locked by magic, type of box. We can draw some ruins on it or cut out some foam ruins. And so we're going to figure out the dragon part the next stream. And so getting back to, this guy here, the MOSFET, you can see has a heat sink already attached to it. Pardon my obnoxiously long screw. The screws that came with this heat sink were too short for this MOSFET. And so looking at the MOSFET, and hopefully I'll do it in the correct orientation here. I'm grabbing my pointy pen. It should go gate, drain, source. So the gate is the pin on this side, and the drain is in the middle, and the source is on the other side over here. So it basically acts like a switch that will mimic the oscillations coming from the 555 timer and then amplify the current, coming from this thing. So that way this adapts the square wave from the 555 timer and pulses that into the light bulb. So let's, see if this thing even works, right? And Dave Beck is saying more screw, more heat sink. Listen, I'm not gonna lie, I was thinking the same thing. I'm like, I can just put screws all up in this thing. And normally I use, the heat paste, but these came with these little insulators here. And I read, you don't mix the two, either the insulator or the paste. So those of you with more experience, you can chime in your suggestions, but I just kept it with the little insulator on. And now let's hook up this MOSFET and see, if we even get power from this thing. So here is my ignition coil. I'm like, words. So let me give you guys a closer look there, and you can see the common ground, the one input. Now, normally for these projects, I'm used to seeing two inputs. These are super easy to install in, a scooter and things. But for electrical projects, I was like, wait a minute, I'm used to seeing two of these things. And of course, this is our high power output, our high voltage out. And you'll notice it's naked on top. I went ahead and cut its booty off, and of course this goes into the spark plug there. And so I'm going to put this bouteille on the side because we don't need it anymore until you can see the raw wire coming out of there. That for now we'll use alligator clips just to kind of hook all this stuff up and see how it works. And that scene is great for seeing stuff. Chops off my head a little bit, but this is more important. This is way more important. So we have our breadboard, and let's hook up our MOSFET to our high-powered source here. And let's see if we can wake up this thing here a little bit and see if we can get, a little bit of time from it. There we go. We'll move quick. People. Otherwise, I'll just use the other view. So looking at this, and I'll tilt it for you guys to see. Let me grab my stuff here. We're gonna hook, remember pin 3 right now is hooked up to our LED, and I left that on because it's a great visual indicator of kind of like what's going on. So I'm also gonna tap into pin 3 again, and we're gonna hook that up to our gate, which is all the way over here. So it's this pin right here. And then after this, we won't really need that camera anyways. And then I'm going to go ahead and hook up our, source here to the ground rail. So I'm going to bend this back here and just kind of put him back here. So we have pin 3, the out, that's going to be sending those pulses going to our going to our gate. And then we have our source already connected to our ground. And now we just have to hook up that drain, which is going to get hooked up to our nice fat, condensed ignition coil here. So let's get that going. And so I'm going to put one of these little DuPonts here into the middle pin, which is our drain. There we go. And this has got to now hook up to here. So for that, I'm going to use a matching alligator clip, and I'm going to alligator him. I'm going to chomp him, and then I'm going to chomp over here like that. And here's, our input, and we'll be getting to that shortly. And so now our MOSFET is totally hooked up there. So you see it coming, this one being one of the more important ones. You want to make sure that your gate is indeed connected to pin 3. So like before, where, I didn't double check my glasses situation. So yes, that indeed is hooked up to pin 3. All right, so we're ready to go there. And let's finish hooking up our ignition coil because it's gonna need power. So here I have a little barrel jack adapter. I have 2 cables already coming from it. So I'm gonna put this over here. Let me start moving these things kind of like out of the way in preparation. And I have our barrel jack here. I'm going to face them this way because we're going to be plugging in here. And so this red wire needs to connect. I'm going to bring them back over momentarily to our input. And in order to do that, since I'm on a roll here with these alligator clips, I'll go ahead and chomp this guy and I'll chomp him onto here. There we go. And now we have to hook up our negative here. And I'm just going to give this a twist. And I'm going to go ahead and connect this to our ground rail. So let me find a little space. I'll go back here, behind the MOSFET here. We're going to hide behind here. Although this heatsink is a bit gargantuan. So we'll do that. And rather than twist these together, I think I'm going to stick with the chompers. Get our little alligator clips right there. And I'll clip him and clip him. And then we'll move these wires so they're not all so touchy-feely. And now we're ready to hook up our power supply. And oh yes, so first we also want to, and that camera's going night-night. So the first thing we're going to do is give power to our 555 timer, which is going to be powered by this 9-volt battery. And once we get that hooked up, I'm going to go ahead and hook up our high power voltage. And we are going to see if it even works. So high voltage is going to come out of here. We got to make it go somewhere. So let's see. I'm going to chomp this. And the first thing we can do is see if we even get an arc and kind of mess around with our oscillator a little bit. So for this, I have my most famed, check this out guys, not a harpoon, although I guess you can use it as a harpoon. This is what I call my chicken stick. Yes. When it comes to high voltage, I'm a little careful, so there might be some quiet times when I'm concentrating. But yes, this is my chicken stick. I am not afraid or embarrassed to admit when, something's a little scary, And so I'm going to go ahead and connect this to a nail that is electrically taped to something that's non-conductive. And then to be extra chicken, I have these oven mitts that have a rubber coating. Now, this is super ridiculous. I know you guys are just like, oh my God, you're overdoing it, but it's high voltage. So of course this goes without say, but I'm going to say it. Careful with high voltage at home, especially if you don't have experience doing it. Take your time. And that's not to say, don't do it. I see a lot of people are like, if you don't know what you're doing, you shouldn't be doing it. Obviously, get help. Work with somebody who has a lot of experience with this stuff to help guide you. But the most important thing is take your time and don't touch, anything before turning it off. If you want to make an adjustment, turn it off first, of course, except for our potentiometer, because we'll be able to safely adjust that. But anything else, if you have a question why it's not working, just turn it off first before you continue. So, all right, that goes without saying, although I just totally said it. So let me prep myself here, and we have a, plug in here, and this is a 12 volt, 3 amp output. So that should be enough, to kind of get things started. And I'm going to do this with lights on first, and then see if we see anything. We might have to turn the lights off. So the first thing I'm going to do is prep this camera here. That way I'm not maneuvering high voltage and trying to give you guys the best view at the same time. We can already kind of maneuver this in a place where you can see. And let's see, I'll put a screwdriver here. Maybe we can get like a cool arc happening there. And let me move these things closer to me. So I'm just kind of like prepping, getting everything ready. I was able to get arcs from this guy over here, and let's see that I can use the wand pretty easily here without it knocking anything, down, so, we can touch different things. All right, so this is looking pretty good, and I'm going to put that there. I'm going to put safety glasses on. There's nothing that really is going to explode, but you never know. Better safe than sorry. And for now, I don't see anything really wrong with our connections. That all looks like it's going to be hooked up right. We will soon find out, though. And I'm going to leave this potentiometer all the way down. All right, so we should be good. We don't have any kind of wires touching to short anything out. And the first thing I'm going to do is maybe turn this light off right up here. Let's turn our overhead light off a little bit and see how that works out. And I'm going to start by powering on our 555 timer. David Beck is saying, I need one of those. I'm going to suppose he's talking about my chicken stick. And it comes with the sound effect, the baka sound effect. So now that that's done, I have my oven mitt here ready. I'm going to plug in without touching the metal components. I'm going to go ahead and plug this in, and I'm going to be quiet. For once, I'm going to be quiet because we're going to listen for these spikes or arcs. Now we hear it going, and let me put my my extra chicken mitt for extra chickens. Whoops. Let me turn that off. And that's what I mean. Just take your time. If something drops, falls, don't go in on it. Just turn stuff off first. And let me see if I can get a better clamp. Sometimes if you clamp it right on the tip of the alligator, it clamps better than trying to clamp, all the way in its throat, I guess. So we have our 555 timer on. I'm going to go ahead and back it on up with my extra chickenness. And before I do that, let's turn on our high voltage. All right, so yeah, definitely we don't want to be touchy over here. All right. And I'll move a little more slowly. Let's see if we get any kind of arc. Now, I don't see an arc, but I definitely hear. Oh, look at that. All right, so we're getting a good spark there. I'm gonna go ahead and put the chicken stick, and I have a place where I can kind of anchor it so it doesn't fall over while I turn this on. Famous last words, don't fall on me. There we go. So now it's safe to touch. And one of the things that I'm going to do is move this closer to you a little bit so you guys can see it all in action. And why don't we close the lights or shut the lights off? So I'm going to go ahead and just unhook this little guy, and I'm going to not put you guys on intermission, but I'm going to dim the garage lights. So I'll be right back. You'll see that I need like a clapper or something, clap on, clap off, and see what happens. As in, by dimming, I mean turn them completely off. So let's see if we get a much better view here, and I'm going to set the view up for you guys. And I'm going to actually turn one of these studio lights off here and see if we can get like a nice spark going. So here we go. Step 1, turn on our 555 timer. And also, just to recall, anytime you're arcing this way, it does create ozone. So you do want to be mindful of that and work in a well-ventilated area. Jacob's ladders, all those kinds of things create ozone. So all right, we have this hooked up. None of the wires are touchy-touchy. And we're gonna focus our attention on here as I turn this on. I'm putting my glasses on, although, you know, there's nothing really here to explode. Putting my chicken mitt on and grabbing the chicken stick. So we are extra chickened. And I'm backing up as I have this, and let's see what happens. All right, we're getting some cool sparks. So this confirms that our hookup is working correctly. So I'm gonna put my chicken stick here. Kind of anchor it, and actually let me just get this. There we go. And let's turn off our 555 timer. Now I'm going to turn back on the lights, and we're going to hook up the light bulb now and start like really messing around, right? So give me a moment here. All right, lights are on so we can see what we're doing. All right, chicken stick. Good job, chicken stick. You're a good assistant today. So I'm gonna put you, I don't think we need the chicken stick really. So I'm gonna put him aside and he can just kind of like observe, you know, what we have going on. So this is a regular incandescent light bulb. I believe it's a crystal clear 40 watt, you know, so I took it from, you know, one of the ones I have here at home. And this base, it's like $2. It makes it easy to connect from the bottom, and we're only going to be connecting, you know, using one connection. But I also got this because I'm like, this is kind of a good thing to sit on top of a box with our components hidden inside, and then we can build or mold like a dragon around it. And I'm sure we can conceal this. Like we can add grass, we can add like do a whole like, you know, miniature scene with it, or it's holding the orb with its little feet. So I thought, you know, for $2, this is a good start. Or if you guys want to build something simple, say you don't want to dragon it up, well, you can simply put something like this on, paint it, and attach it to a wooden box, you know, so it's well insulated. So there's a lot of cool, simple ways to make a cool plasma lamp. So last step, I'm going to turn on the one light that I turned off, and I'll be right with you guys. And there we go. We've got light, just so we can see kind of what's going on. All right. So 1/2 inch to 3/4 inch spark. That's what I think. Now, again, we were running 12 volts. If we were to up the voltage, then I'm pretty sure we would be able to get quite a decent spark. So one of the things I'm going to start with is making sure, wrong little device here, that this potentiometer is turned all the way down, so we can start from the beginning and start cranking it up. And the objective now is going to see at what frequency we get all the maximum striations. So I think the best thing to do is do this completely in the dark. So I will turn the lights off after all this is hooked up, and I will stumble my way back, you know, and then we'll start messing with it. Now, this is a great first step to building our, you know, a real plasma ball, because the circuitry is really not the problem. That we can figure out. They have circuits online for plasma balls. This is the toughest part, in which you need some kind of chamber that is insulated. So most household light bulbs are filled with argon. And plasma balls tend to be filled most of the time with neon. Neon is what gives you that kind of orangey type of striations and tentacles. Also, argon will tend to give you more of the blue colors. Xenon, krypton, you know, so there are a couple inert gases inside a plasma ball. This one most likely just has argon. And because the striations are blue, it's tougher to see with the naked eye. So that's why we're going to turn off the light, and then there's ways to make it look better, you know, in the light. Also, we can try and find light bulbs with different gases in them, so we're not just stuck with argon. So the biggest challenge of building your own plasma ball is actually building some kind of acrylic ball. Glass is probably better so the acrylic doesn't melt. And finding a way to make either a vacuum or even better yet, pumping in some kind of inert gas. Because the early light bulbs were vacuum. They were mostly a vacuum, but what they found is that the tungsten filaments decay really quickly, and those light bulbs, just the surface would all turn black. So they found that by adding an inert gas, or noble gas, it preserves the tungsten a lot better. Your light bulb lasts a lot longer. And by sealing it and not letting atmospheric oxygen get in, you're much less likely to have something catch on fire or burn. So when you see a light bulb that's either caught fire or burned, most likely it's lost its seal and atmospheric air has gotten in. And when you get a plasma arc, if there's any oxygen around or molecules that contain oxygen, it splits it. And that's why when Jacob's ladders or any high voltage experiment where you see arcs, you start to smell that ozone. And it obviously is not good for you. It's horrible for your lungs and all that. But because we're going to be running it inside a light bulb that's contained in argon, gas, then that should really, not really have the ozone problem. And so that's why they also encapsulate Jacob's ladders inside tubes. Number one, to get a better arc and prevent the wind kind of, from damaging it or moving the arc around. But also it really helps reduce the ozone that's kind of getting into the air. So we did a couple sparks there, not much, ozone going on. And then the ozone will eventually, combine back to regular oxygen, water molecules, all that kind of stuff. So eventually it unsplits and rejoins together again. So those of you that have used purifiers to kill mold, that's ozone. And so that's why they say leave the room for 30 minutes to 4 hours, and then that all unsplits, those split oxygen molecules then rejoin, into other molecules. So then it's safe to breathe. So I don't think we're going to need our chicken mitt anymore. And I think for now I'm going to stick with the 12 volts and let's get this arranged. I think all we're going to do is take this high powered thing, and instead of connecting it to the chicken stick, I am just going to connect it to the bottom here. And I'm connecting it so the plastic clip is kind of on the bottom and kind of does that. So it's going to be a little crooked, for us, but let me make sure that this view here is good for you guys. And let me move this wire kind of out of the way and see what happens. We are going to be turning the lights off. And so let me position this ahead of time in a way where there's no touchy. All right, all the wires are by themselves. And let me grab the battery. So this is ready to hook up here. And I think we can try and go for it. And all I'm going to be doing in the back here is turning this potentiometer until we get maximum striations and tentacles going on. So let's see. Do I have everything ready? I believe I do. All right. And I also have a cool Edison bulb that we can try as well. So I'll be right back. I'm going to turn every single light off. And except these kind of back ones so I don't trip myself. Coming back. All right. And one more light. All right. So first I'm going to hook up our 555 timer. And in the dark, I'm like, which one's red? Which one's black? We'll find out soon enough. Oh no, now putting them in their little holes. I did not anticipate. There we go. 1 and 2. So we want to listen for and look for a lot of corona. And you'll hear it for sure, I suspect. So there we go. Everything is moved out of the way. And I'm going to go ahead and plug in our high voltage. All right, so this is kind of annoying. Maybe I'll do this so you guys can see. And now, if you look really carefully, there's a streamer right there I don't want to get too close. If you're watching, it's on your right side. No, left side. Maybe there's a tiny one on actually there's streamers on both. So let's start to kind of like jack this up and see what happens. And you have to go so slowly, but you see the streamers are getting more intense. Oh, then it went off. Oh, look, now they're just pulsing. Let's see what happens if I turn it off. Turn it up. And the MOSFET's getting nice and warm. It's right next to my hand. Whoa, I hit something. All right, so you can hear the corona too. And looking over at the ignition coil, we want to make sure that we're not getting any type of leakages, like high voltage leaks. I don't see any. I'm going to keep cranking it higher and higher to see what happens. It's a very fine point, probably, when we're going to get like because I'm barely touching this potentiometer, and we can hear the pitch, which is kind of annoying. Oh, it's getting good, guys. Look at that. Uh-oh. Some of the electronics in here are going crazy. The iPad just freaked out. So I know for some, they've complained that it does shut off cameras. So if the cameras go down, give me a moment. I'm going to shut this down and restart cameras. So don't panic. All right. And I'm still looking at our ignition coil here, and I'm not seeing any, anything. And this is annoying because it's tough to see with this light. This is a poor choice. I might undo the light. Oh, guys, that's a great frequency. Look at that. All right, that might be too much. That we might have passed it. Yeah, we might have passed it. So I'm going to try and back down to where we were. Like right about there, guys, right? All right. That's looking pretty good. And let's see if I can turn this in a way where this stupid light is not, or I'm going to put my chicken mitt. There we go. Hide the light, chicken mitt. So that looks pretty cool. And Dave is saying, I was going to ask if you tested the cameras. I did earlier, and I didn't have any shutdown problems. The only shutdown problems that we have periodically, and let me fix my iPad here as I talk to you guys. The only shutdown, woo, that's scary. So the only shutdown problem that we've had intermittently is, Whoa. All right, so let me shut this off so we can actually, All right. So yes, that is so funny how like this, so I tested it with the cameras and the cameras are fine, but I did not test it with my switcher. And yeah, it just did all kinds of jacking up with my switcher. It turned the mic off apparently because you guys are complaining. So hopefully it's back on. I see the levels are moving. So it should be back on. And I'm going to quickly just turn the lights on because this is creepy. Although it's very, timely for this. So if one of you guys can give me a quick, like, hey, we got Mike in the comments, that would be great. And And Dave Beck is saying, I'm surprised the mics are freaking out with the noise. Yeah. This was, I didn't test this with the mics, so I'm glad that the computer is good, so it didn't shut down there. But this was an interesting experiment. I'm glad that, the camera stayed, but the switcher is definitely affected by it. So for next time when we're building our dragon and stuff, I'm just going to have to put it like by the computer and be switching, from up there. So Frozen Mustache has confirmed that, yes, the mic is up. And then Dave Beck is saying, yes, we hear you. So let me turn the lights back on because this is campfire story time. And all right. So I'm just double checking that, yes, the mic is on. So I think that looks pretty good. And again, because we're working with argon inside, we're going to see the blue streamers, and that's about it. I do know that they make neon light bulbs, so I'm going to try and find one of those. So what I want to know from you guys is shape of light bulb. I believe last time we talked about orbs, if we want like a giant one with a dragon, or if we want like a smaller orb thing that the dragon is holding with its feet, so that means we'll have a smaller light bulb. And so, Dave Beck is saying, I like the early Halloween scene. Yes, we're working up to our Halloween project, so we got to decide on that. So there's a ton of decisions going on here, and just confirming everything is off, I'm going to go ahead and undo this because I'm kind of curious to test the Edison bulb. And to do that, let me go ahead and move this switcher. Let me see if I have enough cable here out of the way. Maybe if I put it all the way over here, it'll kind of calm itself down a little bit. So kind of away from the stuff. And the mic, yes, I should have warned you, the mic might act. Hopefully you guys didn't like blow your ears out, or anything like that. So let's see what happens now that we have kind of a frequency situation. That's not hot at all. Going on. Oh, one other thing that we can do, say something like this is going to be visible in the light, but it's not going to be as spectacular as we saw in the dark. This is very much a lamp to use in the dark. And I was also thinking maybe incorporating some glow in the dark paint into our dragon. So when you dim the lights, the dragon not only glows, but you have that plasma ball as well. So I thought that might be kind of a cool idea to attempt to do. So other ideas to get even more streamers that we can try is just resting a washer on top. And what you're going to notice is that those streamers are going to gravitate towards the washer. So it could be something where you can hide a washer on each hand of the dragon, so the streamers go to the dragon's hands, so it looks like the dragon is like powering it up or something, and we can hide something like this underneath the dragon. The other thing that I've seen people do is actually use aluminum foil. And so all you would do is take a little bit of aluminum foil and stick it, where you want the streamers to form. This makes it a lot easier to see the streamers during the daytime or when the lights are on. So those are some of the things we can do. Now, if you're running something like 19 volts, having those streamers hitting the exact same spot over and over and over again does start to get that glass hot, and you don't want the glass to melt. So it's kind of nice to let the streamers just kind of dance around wherever, they may want to dance around. Try all the bulbs you have and want to try. All right, let's do it. So let's do the Edison bulb. And they all have like cool different effects. We can do like a flame, bulb. I have mostly LEDs at home. I'm sure like a lot of you guys. So I try to go through my stash and see what kind of like, what kind of incandescent situation I have. So I just went ahead and connected it again. And let's make sure that this is totally visible to you guys. Okay, and what I'm gonna try and do is move this thing was kind of being annoying. Maybe I can move it all the way over here so that light doesn't disrupt you. And I'm gonna move, ooh, that guy's hot. I mean, not like hot, but you know, a little warm, and he's dissipated, so he's good, the MOSFET. So hopefully that little red LED there, I'll put the chicken mitt there if I have to. So let's do the same thing, only this time, I think I'm going to hook this up first, because this is incredibly hard to see in the dark when you're trying to hook it up. So we have our 555 timer. I didn't touch the, the potentiometer, and all I'm gonna do is start shutting lights down. Start shutting it down. All right. And again, to remind, if any cameras go down, just bear with me, and I will try to reset everything, and it might go a little haywire. All right, so I'm gonna go ahead and make sure, oh, that's a nice piece of metal right there. That's not good. Make sure things are out of the way. Generally, speaking, we don't have any cross wiring where we can get any shorts. Make sure, and no touching. All right, and we have our light kind of back there. So here we go. Oh, Dave has a good idea. He says, use the aluminum foil to block the light. There we go. That makes it a little bit better. So here I go. I'm going to power it up, and it's going to be like, so watch your ears. Now, going to start messing around with our frequency here. Oh. All right, I'm not getting anything from this thing. So most likely when that happens is because it's the wrong kind of bulb. It's not like incandescent. I know that it's not LED for sure, but let's start all the way from the bottom and work our way up. Now we're getting the pulses, but no streamers. All right, so this one was a fail, this light bulb. I'm gonna turn that all the way down. Kind of a fail light bulb. So we're not gonna be using any Edison bulbs, that's for sure. There we go. So no Edison bulbs for us. Let me unplug this, and nothing going on there. Now, running 12 volts through a light bulb is safe to the touch. So you could touch it and you'll get like all those cool streamers and stuff. So I kind of would like to try that, while we have the lights off. And periodically after touching the light bulb, I like to use either rubbing alcohol or a Windex to get your finger oils off of it, because where you touch, those finger oils start to get the glass really hot. So it's nice to just clean those off from time to time. So I'm going to do the same thing where I'm going to shield our thing here. And turn on our light. All right, so you guys don't see much of the red. And Dave Beck has a really great, saying that yes, failure is learning. That's in fact how I learned everything, is by face planting quite a few times, and the more you face plant, less it hurts. It's like your face develops calluses or something like that. So you get very good at it, but yeah, you learn a whole heck of a lot. So just kind of double checking that nothing came loose before we give this another go. And let's do it again now with the bulb that we know works, and we're gonna set our potentiometer situation here. And in the dark, I'm just like looking for this little screwdriver thing. There we go. And I remember just by feel, it was kind of like, you know what? That is not very visible for you guys. Let me go ahead and move this. So I turned it off, and it's kind of dark, tough to see. And I have the wrong angle for you guys. There we go. Sorry about that. I was being totally lame. All right, here we go again. There. And I'm going to just turn this for you guys. And I'm going to use the chicken mitt for you guys to see it. As I turn the potentiometer, let's try and get those streamers again, because I ruined it with the Edison bulb. And hopefully the cameras can, all right, here we get our pulses. And I remember it's past these pulses that it starts to get really cool. And it should be safe to the touch, but my chickenness is making me not touch it. All right, maybe a little more. That's pretty, look at that. Oh, now look at those streamers are getting angry. That's awesome. Whoop, long chicken stick. I'm just touching it with the chicken stick, and there's a very tiny streamer that follows the nail along the top. I don't see it on camera, you know, so I doubt that you guys see it too. So that's pretty cool. And let's see here, I have a piece of aluminum foil. I'm gonna stab it with my chicken stick, and I'm going to put it near it. Yeah, definitely the corona changes. But that's really cool. In a lamp, this is gonna look awesome with our little, you know, our little dragon guy. So guys, success. The 555 timer idea to post these rays worked. You know, it's not exactly like plasma ball level, you know, but that a lot of that has to do with the fact that we're working with argon here and not maybe like a neon. But I'm gonna see if maybe there is a neon bulb. I know they make them, so you know, I'm gonna see if I can find one and then see what kind of size bulb you guys want. I can try and find like a really friggin' big one, you know, or something that's more smaller orb size. But I think big would be cool. And David Beck is saying he can hear the frequency changes. Yeah, I'm going to not touch the potentiometer because I kind of like this where it's at. And, you know, I think we're pretty good here, and we can try different bulbs. At least I'll know I'm close, you know, that the frequency of our timer circuit is in resonance, you know, with the coil. So I know that we're going to be close. And that frequency is really annoying, so I'm going to go ahead and undo it here. There we go. The light show is off, and I'm also unplugging this little guy back here. And I'm going to change views here. And our switcher liked it a lot better over there. It didn't freak out as much. Let me turn on some lights, and I'll be right back. Light number one. Couple more lights so we can see. Behind you. I'm behind you. And now I'm back. All right, so I don't know about you guys, but that was like way too fun. I had so much fun. And this is just a simple 40-watt light bulb. I'm gonna try different shapes and sizes. Maybe we can get different kinds of streamers, but the biggest thing that affects your streamers is the gas inside. So neon, I think, is what I'm going to aim for, because I think that's the biggest gas. Out of the gas composition, neon is the gas that's in them the most, and then a couple other gases. So that would give us kind of our orange, into our plasma, although the blue is really pretty too. So it did kind of give me ideas about maybe making this kind of a very nighttime dark spectacular. And right now I don't smell any ozone, so that's kind of nice that it's contained in the light bulb. If I were smelling ozone, most likely it would be coming from some voltage leaking situation going on here. But I didn't see any corona or anything like that. So I think by the time we build this, we'll make sure to insulate all the wires really well, use some nicer gauged wires versus my little tiny little alligators here. The MOSFET did fine. It's just a little bit warm. And the only thing that we could try is a smaller capacitor. One thing I did was switch our 100 microfarad capacitor to a 0.1 microfarad capacitor. Generally, these are done with capacitors in the nanofarad range, anywhere from like 1 to 100. So I thought that worked a lot better. I was able to get a lot more streams by doing that, but the circuit otherwise is totally the same. So hop on Discord, tell me your ideas for this next phase, because this is where we're going to start building the dragon. So we need to kind of know how big this light bulb is going to be, how we want the dragon positioned, if it's holding the light bulb, if it's has the light bulb in its mouth maybe, and then we'll run the high voltage through its neck, and it's holding this orb or something in its mouth, like it's going to breathe fire, but it starts as electricity or something like that. So that might be kind of fun. And at this point, I'm not quite sure how I'm going to build the dragon. I think I'm going to take the very first stab at trying to build some kind of wire armature plus foil plus clay type of situation. And then if that looks like it's kind of derailing and not going in a good direction, we'll try foam miniature, stuff, just like we did with our Frankenstein castle. And that should look, pretty good too. Worst case scenario, say I miserably fail at all this whole dragon thing, and this dragon looks more like a unicorn or a pony or a butterfly even. We can always buy some kind of pre-made dragon, like a model or something like that, put it together and adapt our lamp that way. But I think using some glow in the dark type of things, because that's how this will best be seen, might really be cool, So let me know. And Dave Beck is saying, I gave you a thumbs up on UT here. Awesome. So we pretty much are done figuring out all of the electronics. So now it's the prettification step. How do we prettify this and make it into a very cool, awesome looking lamp? So that's going to be for next Wednesday. And I will see you guys again next week, where we're going to jump back to the barbecue Duino cart. And I believe we are starting with our caddy. And as always, over the weekend, this upcoming weekend and last, I've been assembling all of the plans, the wiring diagrams. Now that I know that this works, I can make a wiring diagram out of it, so you guys can replicate it. Obviously, it goes without being said, but I'm gonna say it, be careful. You saw like stuff falling. It's easy to get distracted and get shocked. So I hope you guys learned something. I know I sure did, even though some stuff didn't work. That's when, like David said, you learn the most. And I will see you guys next time. And thank you so much for being a Wrench Army member, because it is because of you guys that we get to do this awesome stuff. I'll catch you guys next week. And I'm going to say bye by reaching over here to my switcher. See you guys. Uh-oh. See you guys. Hold on. It's broken. See you guys. It worked.